Hi Pre-Calc students, Mrs. Fallon here again. We are our last lesson for Unit 2. We're calling this Optimization and Area Problems. You will need a graphing calculator. So if you don't have one, pause me and go get a graphing calculator, or at least maybe open up something on an app on your computer or phone or something that you have, because you're going to need to follow along. All right, so this is kind of a culmination of what we've been working on with some of the calculator stuff, as well as kind of looking at linear equations and quadratic equations and so forth. So what we're doing here is optimization is these are kind of some silly examples that we're going to give you, but we're looking for like what kind of, like if you were going to build build a garden or something, or build something, you wanted to maximize, like what is the largest area, what would the dimensions be to give you the largest area? Or if you're trying to build a house and you wanted a giant dining room, for example, and you wanted what dimensions of my dining room would maximize my area. So those are the types of problems we're doing here. We're going to do some kind of silly situations here, but nonetheless, that's kind of what we're coming up with. All right, so I'm going to walk you through some of these examples and see how we do. All right, so here's what we're going to do. We're going to go ahead and get started. So Farmer Johnny needs to create a rectangular enclosure against a wall. So here's the rectangular enclosure, here's the wall. It says he has 60 meters of chicken wire to work with. Find the dimensions that maximize the area of the enclosed space. So here's the deal. I'm giving you 60 meters. What am I giving you here? Well, if I'm talking about 60 meters, I'm talking about the length. I want to find the area, or the length all the way around that maximizes this area. So we're talking about perimeter. So what I'm giving you here is the perimeter. I'm telling you the perimeter of, like, that's how much I have to work with, 60 meters of chicken wire. I'm going to label, just because, my sides, since I know perimeter is the length around, I only need 3 sides. So X, Y, and then we'll call that X again because it's the same as this one, because it's a rectangle. Find the dimensions that will maximize the area. All right, so first, let's deal with the whole perimeter thing. How do you find the perimeter of a rectangle? Well, you all the way around it, right? So you might have learned like 2 times X plus 2 times Y. In our equation, we have 1Y. So we're going to go 2X plus Y. Because this one is the wall, we don't need to put a fence along the wall, or wire around the wall. I'm also going to plug in 60 into this equation. And the reason why I do that is because I know that my perimeter is 60. All right, we need to maximize the area, which means the area of a rectangle is length times width, or base times height, however you want to look at it. In this scenario, it's X times Y. So we have an area formula, we have a perimeter formula. Guess what? Just like we did it in the last video with like those quadratics and trinomial, we're going to solve a system. So what I want you to do is I want you to take your perimeter equation, and we're always going to solve the equation for Y. So I'm going to subtract 2X from both sides, and then I'm going to substitute it into this equation. So we're going to use, instead of elimination, we're using substitution. So I solved this equation for Y, and then I'm going to substitute it in here. So this, I get X times of Y, I'm going to get 60 minus 2X. So my area equation now is area equals X times 60 minus 2X. So what that does is, instead of having X and Y, which is 2 variables, I now have 1 variable. Okay, grab your calculator. So this is where you're going to need to, I'm going to turn on my light here. This is where we need to go ahead and throw this into our calculators to be able to see. That's not really showing up all that great, I apologize. But anyway, we're going to go to your Y equals. You can kind of see mine in here. Clear out anything that's in there, and let's type in this area equation. So just kind of the way it's written, X parenthesis 60 minus 2X, close parenthesis. So the same way that we would do it in class. Hit graph. All right, so here's the fun part. My calculator, and you can kind of see there, like my window is way messed up. It's way too much on the y-axis, and I can't even see. I need higher, I'm sorry, way too much on the x-axis, and I need higher on the y-axis. I'm going to go to my window, and so on my x max, I'm only going to put, I don't know, 50. because remember it was too much. And then since we're talking about area of a, in perimeter, we're not given negative values. I can't have a negative perimeter or negative area. So I'm going to keep the y min and x min at 0. I mean, you can make it a little bit lower, like mine is at -50 here if you want. Doesn't really matter. The y max actually needed to be a lot bigger. So I don't know, let's try 500. And let's count by tens. You don't have to have the same thing as me. I'm just trying to get a good picture. I want to be able to see this. So anytime you can see this parabola where you can see the top of it, that's what I want. So again, you don't have to have the same window settings as long as you get a relatively good picture is what I'm looking for. All right, so what I'm going to ask that you do for step number, well, I guess we're on step number 3, is I want you to graph it. So here's our graph. It looks like this is our parabola. Remember, we're graphing area versus our length, or x. So area in terms of x. So y-axis is area, this is x. So the important features that you need to know in order to get the dimensions is you need to maximize the area. In other words, we need to find the max of that parabola. So these are going to be the x values to give us the potential areas. The one that's going to give you the biggest is going to be the one at maximum. So that's what I'm trying to find. So I'm going to go back to my graph. I'm going to go to second trace. Oops. I'm going to go to second trace. I'm going to go to maximum. And this is that whole left bound, right bound thing that we did in the last couple sections. So we're going to go to the left of it, arrow over to the right. Remember, use your left and right arrow keys. Hit enter again. I get a maximum of, I'm going to round to 50, 450. Okay. So what does this mean? It means when x, or my length, is 15, my area is 450. So it's not giving me x and y, it's giving me x and area. So my dimensions would be what? Well, if x is 15, one of my dimensions, 15 feet by, so 15 times what gives me an area of 450? Well, you can either plug it back into this equation. Remember how we plugged this in and got, we could go plug it back into this equation, I should say, to solve for y, like 60 minus 2 times x, or 60 minus 2 times 15. Or you just take 450 divided by 15. I don't really care. Either way, you're getting an answer of 30 feet. Well, what area is the highest area? Well, if you look at our max, what did we get for our y value? It was 450. So we get an area of 450 square feet at the max. All right, the rest of these are different variations of this. So let's go to another one. Farmer Johnny expands his operation. He now needs 5 adjacent pens, rectangular pens. So I didn't give you a picture on this one, so let's draw one. So 5 would mean that there's 1, 2, 3, 4, and I drew 6, so let me erase one. So 1, 2, 3, 4, 5. 5 pens. So if this is my x, right, and this is my y, from here to here. You can make it the other way, it doesn't really matter. So I'm going to call all of these need to have wire on them. So I need to have wire here, 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 all the way around. So I'm adding a lot more wire to my little pen here. Instead of having one big open pen, I'm having 5 individual ones. So that's what that 5 adjacent rectangular pens means. He buys 5 times as much chicken wire, which means he has a perimeter now of 300 meters. So that's how much he has to work with. So let's write our perimeter equation. So perimeter, which is 300, equals, so we have 2 x's, and how many y's? Well, 1, 2, 3, 4, 5, 6. We need 6. Unless we assume that if he's against this wall, right? So I guess if we assume he's against the wall, then I guess we only need 5, because we wouldn't have to count this one, right? So it only have to be here, 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 and here. So we'll call that 5y. And that's because of that wall there. All right. So again, remember I said take your equation, solve it, for y. So I get 300 minus 2x over 5 equals y. So the next step is to do the area, which is x times y. And since now we know we're going to substitute this value in our equation, we're going to get x times 300 minus 2x over 5. So that becomes the equation we're going to put into our calculator. So this is now the equation. So we did the system thing where we set this equal to y, we substitute that back in, and now we're going to solve. Okay, make sure, let's go back to our y equals, let's clear this out. Let's type in this equation. So again, kind of as is. In order for you to get the right equation, you need to put parentheses. So I have the x, you have the parentheses here, but you also put parentheses around this numerator. So I'm going to open up another set of parentheses and do 300 minus 2x, close the parenthesis, divided by 5, and close the parenthesis. So as I opened up two sets of parentheses, so the big one and then this little one, and I had to end up closing them both. Hit graph, let's see if we get a picture. Kind of works. Looks like I need a lot more. I don't see where it came down on my x-axis, and I need higher on the y. So higher on the y, let's go up to 1,000, and we'll count by 50s. And higher on x, let's go, I don't know, 200 and count by 10s. Oh, well, at least now we can see where it's down. I just need higher on the y's. So go to your window, I don't know, let's go 2,000. Almost there. Let's go to window, let's go to 3,000. We just want to be able to see the top of it, okay? That's all we really want to do. So you can sketch that on your paper. Again, I'm not looking for anything major here. So if you sketch this on for your graph, remember this is area and this is x, which is the length of our pen. So let's find this maximum point. Second trace, go to max, hit enter for the left bound, hit enter for the right bound, hit enter again, and I get a max at 75 and 2250. So 75 and 2250. Okay, so this was step 3, we did our graph, right? So now we have all the information we need, let's answer our question. So what did we give you? Well, we told you that now x is 75, so this whole length is 75, and so now we need to figure out y. So x times y has to equal an area of 2250. So I'm going to take 2250 and divide it by 75 and get 30. So I know that this whole dimensions is 25 by 30, but I don't ask, so I'm not asking you for the dimension of the whole pen. I'm asking for each individual pen, like each one of these. So instead of calling this 75, I have to take 75 divided by 5, because there's 1, 2, 3, 4, 5 spaces. So that means each of these are 15 by 30. So each pen has a dimension of 15 feet by 30 feet. The total area is still this 2250 square feet, because that's the area of the whole pen that we put together. But each one of those little pens, each one of those little pieces is going to be 15 by 30. All right, a couple more problems. This one says a rectangular gutter is formed by bending a 24 centimeter wide sheet of metal known as shown in the illustration. Find the equation of the area of a cross section of the gutter. Use this to determine where the bends should be made to maximize the volume of the water carried by the gutter. Okay, so we have this. So we have basically, we're cutting off these pieces here. What I want to know is I have this big rectangle here. I'll use a red color. And then I have my other rectangle that I'm bending. So I moved it in so much and I moved it in here so much. What I'm asking for is how much did I move it in? And so that's kind of what we're getting at. So in order for us to do this, I would have to find the area. So I would have to find, like, if I know this is, I would have to find the area of this, which is x times y, right? So this is, we're going to try to figure out this y value. So in order to figure out y, that's going to be a function of x. It would be 24 and minus those two pieces. So again, what we're getting at is so it's a rectangular gutter is formed of bending 24 centimeters of wire. So we're getting at the perimeter is 24. And then we know we have 2x, and then plus a rectangular gutter. So then we're asking for y here. So there's only one y because we're talking about just like this length here. So anyway, if I solve this equation for y, I would get y equals 24 minus 2x. So same as the other one, we're going to substitute that into this equation. So this one was a little bit different. It gave you the perimeter, but it wasn't in quite the same terminology. All right, the process is still the same. So go to your y equals, we're going to go with x times, and then we're going to go, I'm going to clear this out of here, x times 24 minus 2x, close parenthesis. All right, I don't know if you can see way down here, it's a tiny little graph. That window is way too big. So I don't know, we're going to go up to 20 and count by ones, and we're going to go 100 and count by fives. I'm just trying to get an idea. Good enough. All I need to see is to get that maximum. So let's go ahead and go find the maximum. So left bound, hit enter, right bound, hit enter, hit enter. So I figured out my maximum is going to be 6 and 72. So if I drew my graph and it looks like this, my maximum is 6, the maximum area would be 72. So I'm asking about, this is my area, right? And this is x. I'm asking for what kinds of, or how much should I have to cut off on each of those sides. That's this dimension here, because that would be the same. So that means I'm going to cut off 6 centimeters or on each side. So the bends should be 6 centimeters on each side. So that's how much you're going to this is going to go in here and here. All right, that was kind of a weird equation. It's a little bit worded differently, so I apologize for that one. Hopefully that made sense. All right, last one. A farmer has 120 feet of fencing, which is to be enclosed on adjacent rectangular pens. So adjacent rectangular pens, that means there are 2 of them, and they're next to each other. They share a side. So 120 feet. I'm just going to do my work down here since we have some room. So 120 feet. If we know this is x, and we know this is y, right? We don't say anything about a wall this time. So we know that in order to get the perimeter, we're going to have to add 2 x's, and this time 3 y's. So 2 x's and 3 y's. All right, let's plug in what we know. So we know the perimeter is 120 feet. Let's solve this equation for y. So subtract 2x and divide by 3. So again, we're setting up our situation where we're going to solve the equation using a system. So we know the area of this whole thing would be, so x times y. We're maximizing the area. We're going to substitute this number, or all those values, in for y. So my equation looks like this. And again, the reason we do this is because we can't solve an equation that has 2 variables, which is why we have to solve it that only has 1. Let's go back to your y equals. I'm going to clear this out of here. Let's type this in. So x, remember you're going to open up two sets of parentheses on this one. 120 minus 2x, close one set, divide by 3, close the other set. So it looks like this, if you can see that. All right, hit graph. Let's see if my window looks a little off as well. It needs to have higher on the x's and higher on the y's. So higher on the x's, we'll go to 100. Higher on the y's, we'll go to 500. Count by whatever you want. I'm gonna count by tens. Okay, I'm good on the x's. I need a little higher on the y's. So I don't know, go to 700. Let's see what this gives us. Perfect, I can see the top. All right, so this is gonna be where the maximum area is. So again, find that max. Arrow over, hit enter for left bound, hit enter for right bound, hit enter again. I get, and I'm gonna draw my little picture here. So if this is my drawing, right, of all the different lengths, so this is area, and this is my x lengths. I got a maximum of 30, 600. Okay. So 30, 600, perfect. All right, so now I'm asking about the dimensions, right? So if x equals 30, what does y equal? So again, you can always plug it back into this equation here, right? 120 minus 2 times x over 3. That'll give you your y value. But because we're talking about a rectangle, if we know x and we know the whole area, which was 600, we could just divide it. And so I could just take 600 and divide it by 30 and get 20. So that means this is 30 and this is 20. So now it asks for the dimensions of one of each pen. So again, my x value, instead of it being 30, is going to be 15 feet. And my y value is going to stay the same as it was, which is 20 feet. My total area is what we figured out here. Our max was 600 feet squared. Introduction of all of the optimization area problems that we're going to be doing. We're going to do a lot more practice in class. Questions, bring them with you. All right, bye for now.